So today we are going to look over the linear model. We're going to use Excel to graph, and then we're going to use Excel to find the line of best fit and then the equation of best fit. Okay? So first of all, let's define a few things about linear models. So we said yesterday that graphs are a visual representation of mathematical models, right? But we usually either use graphs, we use equations, or we use table of values, right? No matter what mathematical model it is, we have all these three types, okay? So either tables, graphs, and equations, they're all examples of mathematical models. So linear models represent quantities that increase or decrease by constant amount. So we talked about that yesterday, and we said, for example, when we were talking about the earning per hour, right, for a person, depends on how many hours they work, they're going to get paid, and that's going to be a constant amount that they're going to increase every hour, right? If you work for 10 hours, you're going to get $100. If you work for 11 hours, you're going to get 110. So you're going to increase by 10 for every hour. Over an equal or over equal intervals. How would the graph look like for a linear model? Straight line, right? It says it's a linear model, right? So it's going to be a straight line. And then the equation of the line can be written in the form of, what's the form of the equation of the line? Y equal mx plus b, right? Where it's a degree 1, right? Where on the x you have a degree 1. Where, which letter is the slope? M is the slope, and then which one is the y-intercept? B. And the rate of change of a linear function is? But what is it, like for every single, so the rate of change with respect to each other, like how would you define the first difference? How do you know that, what's the first difference? Like what? How would it be for a linear function? First difference is it different? It's the same or is it different each time? It's constant, right? So the rate of change or the first difference is constant. That's what defines linear. If you have a table of value, which model represents linear relation? How can you define linear relations? What do you have to do? In a table of value, what do you have to do?
y2 minus y1
Yeah.
over x2 minus
x1, right? You can do the rate of change, right? So if you do the rate of change, and then you do y2 minus y1 over x2 minus x1. And then if it's constant, then you know it's linear, right? So 55 minus 60, that's negative 5 over 1. So that's negative 5. 40 minus 55, that's negative 15 over 2 minus 1, which is 1. So that's negative 15. 15 take away 40, that's negative 25 over 1, that's negative 25. What can you tell me about this table of value? Is it linear or not linear?
Not.
Not linear. So this is non-linear, and how do we know that? Because the rock or the rate of change is not constant. Okay, table of values, second table of value, again, we're gonna do the rock. Forty take away 0, that's 40 over 5, which is 8. 80 take away 40, that's 40 over 10 take away 5, that's 40 over 5, that's again 8. 120 take away 80, that's 40. And then 15 take away 10, that's 5, so that's 40 over 5, which is 8. Okay? The rate of change in this case is constant, right? Since the rate of change is constant, what can we say? Linear. How about when you're looking at a graph? Which one is linear? C. Right? Because it's a straight line. Right? And then looking at your equations. So the first equation, y equal to x plus 5. The second equation, y equals x squared plus 5.
E.
E is linear. And how do you know that?
Because there's no exponent.
It's degree 1, right? And this is, it's a quadratic, yeah? Because
Degree 2.
degree 2. So this is not linear, right? So it's important to be able to identify using the table of values, using the graph, and using the equation.
I know.
All right. In real-world graphs of linear relations, the vertical intercept represents of the dependent variable. So first of all, what's a vertical intercept? What other words do we use for the vertical intercept? The y-intercept. So the y-intercept represents the, which is, what do we call that value? So if I have this, right, and then this is my y-intercept, what else do we call the y-intercept? Something value. Starts with an I. Okay, give me letters. T? Uh-huh. The initial starting point, right? Your initial. And the slope represents, I said something yesterday. I said, we know this as the slope, or we used to know this as a slope. What was it? We calculated that yesterday, and we calculated it today. Huh? It's a rate of change. I'll take that. Rate of change. Right? So remember, guys, that the slope and the rate of change, they're the same thing. Except the rate of change has units. Like remember yesterday it was kilometer per hour or dollars per kilometer. That's the difference between rate of change and slope. Slope, we don't usually include a unit with it. Okay? So the slope represents the rate of change in the dependent variable with respect to the independent variable. And remember that dependent is your y, independent is your x, right? So your dependent is your y, your independent is the x. So that means this is telling me that the slope or the rate of change is the difference in your dependent over the difference in your independent. Right? That's what this sentence is saying. Let's look at this example. Cup of coffee is reheated in the microwave. The temperature, C degrees Celsius, of the coffee after T seconds can be modeled by the following linear equations. Explain what the numbers in the equations represent, and how do the two equations compare to each other. So I have a 500-watt microwave, and I have a 1,000-watt microwave, and these are the two different equations. Okay? So I have C. C is the temperature in degrees Celsius, and T is the time, depending on how many minutes do I put it in the microwave, or how many seconds. In the 500-watt microwave, my equation is C equals 0.5 T plus 20. In the 1,000-watt microwave, my equation is C equals T plus 20. What's the similarities and difference between these two equations? The same y-intercept, and why is that? That's the starting point, right? If you have a coffee, right, the starting temperature is 20 degrees. Sure, I'm putting it in the microwave with a starting point, initial temperature of 20 degrees. Okay? Now what's happening with respect to the 500-watt microwave? It's going to warm up slower, right? It's going to take longer time to warm up. Now, what does that 0.5 represent?
The step pattern?
It's the step pattern, okay. But what does that mean? Rate of change. So what does that mean? How much is it going up by for every second? 0.5 degree per second, right? Remember, you guys said it's the rate of change, right? So that means it's going to go up by 0.5 degrees per second, right? So if I put it for 10 seconds, it's going to go up by 5 degrees, right? If I put it for 20 seconds, it's going to go up by 10 degrees, right? It depends on how many seconds I put it in. How about in the 1,000-watt microwave? What's happening? How many degrees is it going up by per second? 1 degree per second, right? Because my slope is 1. It's an invisible 1, so it's going up by 1 degree per second. So if I put it for 10 seconds, how much is it going to go up by? 10 degrees, right? If I put it for 20, it's going to go up by 20. All right, so let's write this. So the coefficient, which is of t, which is the 0.5 and the 1, are the rates of change. Of both temperatures with respect to time. Remember we said it's degrees Celsius per second. So we have 0.5 degrees Celsius per second for the 500 watt. And then we have 1 degree Celsius per second for the 1000 watt. And the constant 20 in both equations is the initial temperature of the coffee at T is 0. Okay. Now, most of the time, when we go and collect data or when we go and do our surveys or whatever it is, we don't get the equation, right? We usually get points, we usually collect data, and then we have to graph the data, and then we have to find our equation, okay? So, we can use linear regression to model data that appear to be linearly related. So we call that linear regression. Okay? So when you collect your points, and then you get points that look like this, right? You graph them, they look like this. So you're going to use your technology to find what we call the line of best fit, okay? So it's a line that the Excel sheet will draw for you that best fits your data. And not only that, Excel sheet also gives you an equation of that line, okay? Now, we use linear regression when our points look like they are on a straight line, okay? We don't use linear regression when our points look like this, right? Because this is not linear,
What is it?
right? I don't know. This one? I don't know. It could be, if I have this, for example, that could be quadratic, right? If it's like this, right, it's exponential, right? So it depends on how your graph looks like. Sometimes your graph looks like nothing. That's not good. All right? And then this is where you have to take your outliers out, which we're not going to talk about that right now. Outliers. So there's some data, when you collect data, you get points that don't fit your graph. We call these outliers. So it could be that there is a mistake when you're collecting, or there is like people who don't know and they answered the question but they don't know, right? So these are called outliers. Okay. So for example, if I'm gonna take the marks and then put my marks in, right, and then graph them. Yeah, so that could be one, or for example, if I'm graphing my data here for let's say the class, and then there is one person, most of the people are in like 50, 60, 70, 80, right? But then I have someone who's like at 0, right? This is my, because that person doesn't show up, or that person doesn't do any test or whatever, he's my outlier. I don't include him, or she's my outlier. I don't include them in my data. Okay? All right. So now we call this line that the Excel sheet graphs is called the line of best fit, or LOBF. Okay. And again, as I said, it will give you also the equation of the line. So let's see how that works. So I'm going to open Excel. Now, before we go to that point, usually when I have years, okay, we want to change the years to like 0, 1, 2, 3, but we have to be specific here, right? So if I'm going to use technology for this, I'm going to say these are the age from as 1975 is my year 0, or since 1975. Right? So basically 1975 is my year 0. Okay? What would be 1980? From 1975 to 1980, what is that?
5 years.
5 years. Okay? And then 1985? Okay? So this is what we have here is we have the median age of Canada's population from 1975 to 2000. We're going to say that 1975 is our year 0. Okay? Is our initial year, is our year 0. Okay? So when we put these Excel sheets in the Excel sheet, this is my X value, and this is my Y value. Okay? Always year is on the X-axis, and the numbers are on the Y. So let's see what happens. It's okay for today. You can watch, and then you can try it on another computer. All right, I'm still recording. I don't know if you guys can hear me. I don't know if that's going to record my voice or that's too far.
Can Excel go on iPads?
Should be, yeah. You can download the app.
So it's easier for you to bring that.
I'm just waiting for Excel to open here. All right, so when you enter the points in Excel, you are going to go vertically. We're not going to go horizontally. We're going to enter them vertically. I'm just waiting for Excel to open. I just need you to pay full attention to what we need to do here. All right. So as you guys see, so on the, can you guys see this? So my x values are going to go in the first column. So I have the 0, 5, 10, 15, 20, 25. More than that? Did I go to 30? 25, okay. And then on the y column, we're going to enter the age. 27.4, 29.1, 31.0, you don't need to include that. 32.9, 34.8, and 36.8. Okay, here's where I need your attention. So to graph, you're going to highlight the two columns where you have the numbers. So you're going to highlight the numbers. And then you're going to go to Insert, which is next to Home at the top right here. When you go to Insert, you see these graphs, the different types of graphs. The last one is your scatter plot. So you have to pick your scatter plot. I don't want any lines. I don't want anything. So it will be the scatter plot, which is just the points. And then you should see a graph showing up, hopefully sometime soon. Here we go. So you're going to have a graph. The graph has no title. The graph has no x-axis. It has nothing. You must include a title, and you must include titles for your axis. Sorry? No legend doesn't, you don't need the legend, you just need the axis title. So with this Excel, you can press on the plus sign, and then you can pick axis titles. Okay? You see where the axis titles is? You can pick that, and then you can include the axis title here at the bottom and on the right. So this is going to be the median age. And this is going to be years since 1975. So, what would be a good title for this? The median age of Canada's population. Median age of Canada's population. Okay, so when you're graphing, so now I have the axis title, which I need the axis title, and I need a title, a good title for the graph. Now, this seems to be a little bit like squished at the top. I can change that. I don't have to, but I can if you want. So if you look here, I can actually double click on the y-axis, eyes on me, or on the board. Double click on the y-axis. I'm not repeating this. And then what happened is you have options here. So instead of starting at a minimum of 0, I can start at a minimum of 20, if you guys want. And then what happened is it will kind of shift your, it shifts your graph. So now you have more spread. Okay, your points are spread a little bit more. Okay, as long as you're not missing any points. Are you guys okay with this? Now this part is not a must. You don't have to do it. Okay, just for you to be able to see the graph a little bit better. Yeah. Now here's the important part. How do I include a line of best fit? We used to do this by hand. We don't do that anymore. That's why we have Excel. Okay? So here's how you do it. You press on one of the points, doesn't matter which one. Right click and add trend line. You see where that add trend line is? When I add trend line, I'm going to have different options. So I have the option of exponential, I have the option of linear, logarithm, polynomial, whatever. I'm gonna pick linear because my graph looks linear. Okay? So I pick linear, and on top of that, you're gonna have to click the bottom two boxes. Display equation on chart and display R squared. I'll talk about the R squared later, but these two you wanna display on your chart. So if you look here now, I'm gonna move this a little bit. Now I have an equation. And you see that this equation is y equals mx plus b. Okay? R squared equals 0.9995. What does that mean? R squared is an indication of how good your line is fitting your points. The closer it is to 1, 1 is perfect. That means the line is just fitting perfectly your point. The closer it is to 1, the better it is. Okay? So you see that's like 99.95%. That's very good fit. Okay? So later on, like at this point I'm telling you it's linear. Later on we're going to compare the different linear, exponential, polynomial, right? We're going to compare them, and then we're going to have to decide, depending on the R squared, which one I'm going to use. Okay? So now I have an equation of best fit. Now I can predict what might happen later. Okay, what would be the median age of Canada's population in 2020? Okay? So are you guys okay with this? Now here's another lesson that you need to know for your assignment. So if you can pay attention to me again. So if you're using Apple product, you can always snip using, I think, Control-Alt-4 or something like this. If you're using Apple product, you can, I don't know how you would do it on a iPad, but on a like Mac, you can do FN option 4, I think. FN option 4, that will give you the snipping to take pictures, to capture. Like a screenshot, yeah.
Snapping.
It's snipping.
What is it?
Like what? Do you like cut
Christmas card for Jane.
Okay. Sorry, it's Control Command for, what is it for snipping on
Sorry?
thing?
Control Command 4.
Control Command 4. Nope. How come it's
Can I
not?
just take a picture of it?
Yes, it is. You're hitting function, not control.
Oh, Control Command. It's not working. Control Command 4.
Shift Command 4. Try. There you go.
Okay, Shift Command 4 on the Apple product.
On a Mac or on a PC, you just search snip.
Oh. Oh, wait, just.
Oh, I don't know what your shortcut is. Oh, there you go. I don't know what your shortcut is. I just know you can search snip. And it shows up.
Oh my god, my writing is so...
So I put in my letter to Stacey and said, here's, so I got her a bunch of little packages of nuts and vegan.
Okay, so if you want to take a picture of this so you can put it in the Word document, because that's what you have to do when you're doing the assignment, okay? So you're going to have to search. It's either the, whatever I told you before, option, whatever. Just 1 second. Okay, if you're using a regular PC, you're going to have to search for the snipping tool. So you see, you can search for snipping tool or this tool right here, and then you can take a shot of just the graph, and then you can copy and paste into your assignment.
You don't need like the
Nope,
table?
nope. Just a graph. Okay? So on the assignment, you're going to have to do that. Are we good with that? All right, so I'm going to add this to my
Oh, this on the right. You can do just it only shows the options for the same one. You can click
Okay, guys. Are you guys okay with this? All right. Now, the next question is asking you determine the equation of the regression line. We already determined that, right? So we already have the equation of the regression line. So the equation of the regression extrapolate. extrapolate. So, I have the Excel sheet. That means extended. So you see that forecast here? What I did is I pressed on my line of best fit, okay? And when you press on the line of best fit, you should have this chart. So if you go to the forecast, and then you're gonna go forward because you wanna extrapolate your graph, and then you're gonna go forward to 45 because we just determined that 2020 is 45 years from 1975, right? So you go to 45 and then press anywhere. Now you see that your line has extrapolated, okay? Too much. But 45 is right here in the middle. You can actually, if you actually go and draw a vertical line that goes up to the line of best fit and go horizontal, you see that it's about 45, 44, okay? This is not exact, this is an estimate, okay? But you can also do it using, do the estimate using the graph. Are we okay with this? All right.